Hi guys, good afternoon. So in the last session, we have seen about the fundamentals of firewall, and today we'll go with the evolution that how first of all we had a router, then ASA came in. Okay, before ASA we had fixed firewall. Okay, so we are going to go through that part. Okay, we'll understand with the packet flow that how all these things came into the picture. So let me start about it. My screen is visible, right? Okay, great. So before firewall, we had routers. Okay, and if we try to understand that what was the issue with the routers, okay, and why do we have the firewalls, and how did the firewalls evolve? Okay, so let's consider the case when you have a router, then you have the internet, and on the internet you have some servers available. Okay, let's connect. So this is your internet. Okay, so this is the internet. This is your router you have, and you have your internal network. Okay, so you have your systems connected here. PC1, PC2. Okay, let it be. So on the inside, let's say we are using the network 10.110/24. And here on the internet side, you have 11.110/24. So let's say your public IP is something like 11.110. Inside IP is 10.110. Then after, here you have 10.111. Here you have 10.112. This one you consider it. Let's say this is YouTube. This is Facebook. And consider this is one of your other branch of your organization. So this network, it is available in the Bangalore. Okay, let's say this is available in the Bangalore, and this is your Delhi branch. Okay, so for YouTube, let's consider the IP address something like 100.1.1.1. For Facebook, let's consider it 150.1.1. And for the Delhi branch, let's consider it something like 30.1.1. Okay, these are some of the IP addresses I have considered here. Now what? whenever somebody is going out, okay, from inside to outside, if anybody is going, or outside to inside, if anybody is going. So what is the default behavior of a router? What is the default behavior of a router? A router allows the traffic. Okay. Router will do what? Router will just allow the traffic. So let's say if this guy, okay, just consider, let's say you have an internal server. Okay. You have a server on the inside. And here you have configured the IP address 10.1.100. Now what will happen? Here you have configured the HTTP service. That means port number 80 is open. Now let's consider the case when anybody, let's say your Delhi branch is trying to access your internal server. So your Delhi branch is going to generate traffic, generate a message, and in the message, it will have some information. Okay. What is the information it is going to have? It is going to have information about source IP, destination IP, then it will have information about source port, destination port. Okay, so source IP will be what? In short, let's call it 30.1. Destination IP will be 10.100. What will be the source port value? What will be the source port value here? Yes, guys, what will be the value of the source port? Can anyone tell me the information about source port? What will be the value of source port? No one? Source port is randomly selected. Okay, this is randomly selected. So your PC will randomly select, let's say something like 45555, like this. Destination port. So it wants to reach the service HTTP. So it will use the destination port number 8. Okay. So guys, what is size of port number? If you guys can tell me, what is the size of port numbers? Sixteen bit. So what are the total number of ports? 0 to 65,535. Okay, so can you tell me about the reservation, how they are divided now? Okay, so the size of port numbers is what? It is 16 bit. So total number of ports you have is 65,536. The range starts from 0 to 65,535, in which port number 0 to 1023, they are known as well-known ports. These are known as well-known ports. Port number 1024 till 49,151. These are known as registered ports. These ports are known as registered ports. And 49,152 to 65535, these are known as dynamic ports. Okay. Or ephemeral ports. So your PC will randomly select a port from this range whenever it will initiate the communication. So the dynamic port range, so it will be not like this. Here you can consider it something like 49. This is how it will generate. Now what? This message will be forwarded here. Will come to the router. Router will check what is the destination. 10.100. So what the router is going to do? Router is going to forward the message here. The router is going to forward the message to the server. Okay. Now, this is one scenario. This is one scenario we have. Now let's consider another scenario. Okay. Let's consider another scenario that there is a hacker on the network, on the internet. There is some hacker available. So let me have one more machine here. This is a hacker machine. This is a hacker. And let's say the IP address he has is something like 40.1.1.1. Okay, this kind of IP address this hacker has. And somehow this hacker came to know about your web server. So now this hacker will also try to access this server. So what the hacker is going to do? Hacker is going to generate a message. And the message that hacker will generate, that will look something like source IP, destination IP, source code, destination code. Okay, so source IP will be what? 40.1. Destination IP will be what? 10.100. Source port, again, it will be some random port or dynamic port that will be selected by your device. Okay, so let's consider again, I'll just call it random only. Then you have destination port, which will be port number 80. Okay. So this hacker will forward this message and message will come to your router. What will be the action taken by your router? Your router will allow it or deny it. It will allow, correct. So your router will forward it and the attacker will be able to access your server. And if your server has a vulnerability, the attacker might exploit the vulnerability and might get access to your server. Okay. So might be the attacker will be able to compromise. So now what you want to do, that you don't want to allow this IP address. You came to know that, okay, this is the IP address that is trying to compromise our server, that is trying to attack on our server. Okay. So I don't want to allow it. So how I can deny this IP address? ACL. Okay. So kind of an ACL I will create here. And my ACL will look something like, let's say on the router, I will say that if source is 40.1, okay, if the source IP equals to 40.1, destination IP equals to, let's consider, for example, 10.100, okay, or let's just talk about standard ACL. So if source IP is this, what is the action should be taken? The action should be denied. Let's say you created this kind of an ACL. That if the source IP is 40.1, the action should be what? Denied. So now what will happen when this particular traffic will come? to your router. What is the action your router will take based on the ACL you configure? Will deny. Correct. So let's say your router will not allow this traffic. So attacker came to know that, okay, using this IP address, he's not able to access. Now tell me one thing, that what if this attacker changes the IP to 40.2? Now he is generating the traffic. The traffic came to the router. What the router will do? It will allow. So is it a good solution that you have denied a specific IP address? So next time what you will do, you will deny 40.2 also. Attacker will change to 40.3. Then you will deny 40.3 also. Then what will happen? Maybe you will deny this entire 40 network itself. Okay. So attacker will change it to 50, 60. There is a lots of possibility, right? So that means this is not a good solution. This way is not going to work for us. Okay, this is not going to work for us. So then, if not like this, instead of denying an IP address, I can say I will allow only specific IP address to come from outside to inside. I will just allow only specific IP address to come from outside to inside. So you have a branch in Delhi, you know that, okay, their public IP address is 30.1.1.1. So what you might say, you might create an ACL, something like that. It source is 30.1. You might say that the action you want to take is what? Allow, and rest everything is denied. Now this guy will, the attacker, this guy will generate the traffic. Traffic will come to your router. What will be the action? Denied. Good. Because it is not matching the ACL, and other than the ACL, the entire rest of all the traffic is dropped. So that means this traffic will be dropped now. Fine. Attacker will try to change an IP address. Okay. Correct. Only 30.1 is allowed. So even if the attacker will change the IP address to, let's say, something like 50.1, then what will happen? Still, this will not be allowed. Okay. Now what? The attacker might start gathering some information. Okay. The attacker might start gathering some information. And maybe the attacker will come to know that, okay, there is a branch from Delhi they are able to access. Yes, exactly. That if somehow the hacker will come to know about this location. So if we think about, your Delhi branch, so let's say the people in the Delhi branch, they want to have communication, so they will generate a message. Okay. Source IP, destination IP, source port, destination port. So they will say IP 30.1, destination 10.100, source port number random, destination port number 80. Now what will happen when they will send it? The traffic will come to your router. Router will check the ACL. Is the source IP 30.1? Yes, it is. Action is allowed. They will be able to access. So if somehow the attacker comes to know that, okay, there is a Delhi branch, they are able to access. So what the attacker can do? Attacker can have two possibilities. Okay, attacker can use two possibilities here. One is the attacker might try to know this IP address, the public IP address. So if the attacker will try to know this public IP address and somehow the attacker came to know about it, in that case, in this message, the attacker might spoof the IP address. Okay. When attacker machine will generate the traffic, the attacker might spoof the IP address. Okay, because attacker is capable of generating custom packets. So what will happen? Now this traffic will go to the router and router will see, okay, is it matching with the ACL? Yes, it is matching, and attacker is able to access. Now this is one way. Another way would be what? That this attacker, he will not spoof an IP address. Let's say this attacker compromised one of the system in your Delhi branch. Okay, one of the system in your Delhi branch, the attacker was able to compromise. And now what the attacker will do? Attacker will generate a malicious message from Delhi branch itself. Okay, rather than spoofing an IP address, the attacker might be able to control a system on the Delhi branch, and from there he might generate a traffic. When he will generate a traffic, the traffic information will be something like this only. The information will come here. Your router will check that, okay, is the source 30.1? So if it is 30.1, the action should be what? Allowed, and this message will be allowed. Your server might be compromised because the attacker has generated malicious traffic from the Delhi branch. Okay, so this is another possibility. So that means even creating the ACL is not really sufficient for us. Is it clear? Now, for this reason, what happened? Around the year 1994, okay, around the year 1994, Cisco brought up fixed firewall. Okay, Cisco brought up a fixed firewall. Now, this was having router capability, NAT. Okay, your fix was having router capability, NAT capability, and basic firewall features. Okay, basic firewall features were also there. And your fix was a stateful firewall. Okay, your fix was a stateful firewall. But there was a problem with the fix. What was the problem? Your fixed firewall did not have VPN facility. And if you wanted to use VPN, in that case, you had to go with a separate device, VPN 3000. Okay, so if you want to see how the fix look like, so fix. So this is how it looked like, the fix. Okay. Picture is a bit small only, but this is, you can see Cisco fix it. So this is how it looked like. But this particular firewall was not having what? It was not having the VPN capabilities, and for that reason, we use the device VPN 3000. Okay, so this is the Cisco VPN 3000. This is how it looks. So that means for VPN connection, you are using a separate device, and for firewalling features, you are using a separate device. Okay. So organizations, they had to go with two different set of devices, and this was working fine until 2005. In 2005, what Cisco did? Cisco brought up a new firewall. Okay. In the year 2005, Cisco brought up a new firewall, which is your ASA. ASA stands for Adaptive Security Appliance. Okay. So your ASA firewall, again, this is a stateful firewall. Okay. And it has the capability of router, MAC, firewall, plus VPN. Okay. So on your ASA, you can configure VPN source. So this is how it was in case of ASA firewall. Now what happened? That when you use a ASA firewall, then how this traffic flow looks like? Let's understand. So here, if we say this was your LAN site or the inside zone, and this was your WAN site. Okay, so here the default behavior was what? allow the default behavior. In case of router, the default behavior is allow. Now for the same scenario, let's consider using a ASA firewall. So this is an ASA firewall. Same scenario we will consider. This is your internet. This is your internal subnet. Then these are your local clients. And same three servers we will consider here also. So same connections we are making here. Consider again, this is PC1. This is PC2. Also, we have a server here. This is your server. This is your internet. This is the ASA. Here we have YouTube. Then we have Facebook. And this is your Delhi branch. IP addresses. So let's say again, here we will use on the inside 10.110/24. This side on the internet side, let's say 11.110/24. This is 10.111. 10.112. This is 10.111. Okay. And here you're running the HTTP service. Here, let's consider 100.111. Here we have 150.111. This one is, let's say, 30.111. And here, let's say on the outside interface, I have 11.110. This is 10.110. Okay, so this is done. Now let's understand the same scenarios again, that how it is going to work. So first, let's consider that this Delhi branch, they will try to access. So when the Delhi branch will try to access, they will generate a message. They will say source IP, destination IP, source port, and destination. Source IP will be 30.1, destination IP will be 10.100, source port will be randomly selected, destination port will be at. Now this traffic will go to the firewall. What is the action your firewall will take? It will block or deny. Okay. So why your firewall will block or deny? because that is the default behavior of a firewall, that the firewall will not allow any communication from outside to inside. Okay. In ASA, we have a concept of security levels. Okay. So, we will have zones like this will be your inside zone. This will be your outside zone. Okay. And in case of ASA, we have security level concept. So like here, security level will be 100. We'll understand it about the security level and how it works. But simply as of now, in one line, you can understand that your ASA does not allow any communication from lower security to higher security. Okay. From outside to inside, you can say. Okay. That is from lower security level to higher security level. So ASA will not allow it. That means this traffic will be denied. Okay. This traffic will be denied. So the ASA is not going to allow it. That means by default, this Delhi branch will not be able to access it. Now, what we'll have to do, we have to go and create an ACL in the ASA to allow this traffic. Okay, so in the ASA, we are going to say that if source is 30.1, destination is, okay, right, this time I'm using extended. Here also we can use standard, not a problem. 10.100. Protocol is TCP and destination port is 80. The action should be what? It should be hello. So let's say this kind of an ACL I have created in the ASA. So now what will happen when this traffic will come? Okay. When the traffic will be coming from the Delhi branch to the ASA will check source IP 30.1 matching, destination IP 10.100 fine, protocol TCP yes, port number 80 yes, action should be what allow, and this will be allowed. Okay. And other than this, if there is an attacker here, okay, if there is an attacker here, in that case, what? This is a hacker. And he has the IP address something like 4111. So the attacker will generate a message. Okay. So attacker will say source IP, destination IP, source port, destination. So source IP will be 40.1, destination IP 10.100, source port will be random, and destination port will be okay. Now what will happen? This traffic will go from the internet to the ASA. ASA will match it with the rules. Is it matching with the rule? No, right? So what will be the action taken? Firewall will deny this traffic because of its default behavior. Correct. Okay. And also this is going from a lower security level to higher security level, and by default your firewall does not allow any communication from lower security level to higher security level in case of ASA. Okay. So this is what is going to happen in case the attacker tries to access directly. But what if in this case also, if the attacker tries to spoof, in that case, what will happen? If the attacker somehow comes to know about the IP address of the Delhi branch and tries to spoof. Okay, so let's say he will spoof an IP address to 30.1. Now what? When this traffic will come to the ASA, what the ASA is going to do? Allow it, right? So this traffic will be allowed. So again, if the two scenarios you consider, okay, one, the attacker will spoof the IP address, and number two, that the attacker will compromise the Delhi branch, okay, one of the system in the Delhi branch, and then is going to generate a traffic for the server. So it will allow it, right? Because in both cases, the traffic will match the ACL conditions. Okay, in both the cases, the traffic will match the ACL condition. So again, is it secure? Yes or no? Is it secure or not? So this is not really secure because this traffic, your firewall is allowed. And also one more thing, that let's say the attacker has done what? Attacker has compromised one of the system in the Delhi branch. He is generating this message from there. Okay. So what the attacker can do, that along with this message, the attacker can attach some extra thing. Okay. After this, let's say data you have, in the data, the attacker will give a payload. Okay. That means a malicious script or a malicious program to be executed on the server. So what will happen? When this information will come along with the payload to the ASA. Now, default behavior of the ASA is what? By default, it will not allow, but it will match with the ACL also. That okay? Is it matching? Source IP, destination IP, protocol, port number, everything is matching. That means the action should be what? Allow. This traffic will come here, the payload will get executed on the server, and the server will get compromised. Okay, because your ASA is a very basic firewall. Okay, your ASA is a very basic firewall. So that means your ASA can filter the traffic based on source IP, destination IP, source port, destination port, just with that one. That means based on layer 3, layer 4 information only, ASA can filter the traffic. Okay. Now, then what to do? Because there is no L7 filtering. There is no L7 filtering. And to filter L7 traffic, okay, to filter the L7 traffic, we need an extra device. Okay, we need an extra device. So what Cisco did, see, in the year 2013, in the year 2013, Cisco acquired a company that is SourceFire. Cisco acquired a company, SourceFire. This SourceFire was known for its devices. Okay, it has 3 devices. One was SourceFire Management Center. Okay. Then SourceFire Firewall and SourceFire IPs. Okay. These were the 3 devices under the SourceFire. So what Cisco did in the year 2013, it acquired SourceFire. Okay. And then later on, it started making modifications into the SourceFire products. And once the 6.0 version started of the OSs of these devices, they became a product family. What? They became Firepower. Okay, Cisco named them Firepower. Okay. So under firepower, we have three devices. Okay. One is firepower management center, which is in short, you call it as a FMC. Okay. So this happened when version 6.0 onwards. Second device, firepower threat defense, which is FTD, the firewall, and then you have firepower next gen IPS, which is your NG IPS. So these are the devices, FMC, FTD, and NG IPS. So this product family, it was released near the year 2015. So firepower came into picture in the year 2015. It was acquired, the source file was acquired in 2013 itself, but meanwhile, before the firepower, they were making some modifications. And if you want to see, like what these devices, they were known as, okay, how it was. So let me show you. Okay, like this it was. So initially, it was source fire. Okay, but slowly it came to be known as what? See, under up till version 5.3, it was under the source fire. From version 5.3.1, Cisco acquired it around the year 2013. This happened. From source fire, Cisco named it to Fireside system. Okay. Then in the version 5.4, it again kept it the name Fireside system. And from the version 6.x, they started naming it as a firepower system. Okay. So the device naming was also kind of like this only. If I show you. Okay, it was not there in the slide. Here you might see it. Yeah, see. So during the version 5.3.0, it is source fire defense center, source fire NGIPS, source fire NGFW. These were the names. From 5.3.1, they slightly started changing. Fireside defense center, Fireside NGIPS, Fireside NGFW. So from source fire, they named it Fireside. Then after, in the version 4.5.4, they started naming it like Fireside Defense Center, Management Center, or Defense Center. Fireside NGFS, Fireside NGFW. Okay, so slightly they were making the changes from 2013. So this was when 2013 your Cisco acquired it and they started naming it as a Fireside. And up till the year 2015, automatically they switches to Firepower. Okay, and now the product family is Firepower. Okay, so this is how it was going on. So these are the devices. Now your FMC, so this is just a manager only. Okay, you can manage your firepower devices using the FMC. Okay, you can manage the FTDs and NGIPS. Your FTD is the firewall. Okay, and your NGIPS is an IPS, and your IPS performs layer 7 filtering only. Okay, your NGIPS performs layer 7 filtering. So then what happened? See, so ASA was there. ASA was not able to inspect all these payloads. Okay, ASA was not able to inspect these payloads. So what you had to do, you had to design your network in this way. Let me just copy this. That here. You needed one more device to be installed. Okay. One more device needed to be installed, which was your NGIPS. So your ASA did the filtering based on L3 and L4 information, and your NGIPS, this did the filtering based on L7 information. Okay. Your NGIPS did the filtering on L7 information. So now what happened? That whenever this kind of malicious traffic was generated, going to the ASA was allowing the traffic, then it was going to the NGIPS. Now NGIPS would inspect your payload. That means the information that is there at the layer 7. Okay. So NGIPS would inspect it and check it whether it is malicious or not. Okay. And if NGIPS finds that, okay, this is malicious, this contains a malware, okay, in that case, NGIPS would drop this information and this information would never reach the server. So this is how the network setup was being done. But again, here also you had to go with two separate sets of devices. Okay, you had to go with two devices. So again, what Cisco did, they had the firewall, TD. Okay, so your FTD was what? Your FTD was combination of your, you can say, NGIPS as well as the ASA with some extra features. Okay, your NGIPS, ASA plus some extra features. That is what your FTD is. Okay. Now, what happens? Let me copy this. Later on, your FTD, Cisco brought up, and as per the FTD, what happened? Firepower threat defense. Or your FTD. Now, according to FTD, what happens? See? It was a combination of your ASA plus, you can say, NGIPS. Okay. This is what you can call it as a FTD. So your FTD is a next generation firewall. Okay. Your FTD is what? It is a next generation firewall. Okay. So FTD did what all the types of filtering, your L3, L4, L7, all filterings it is capable of doing. Okay. So FTD has all the features, your router, VPN, NAT, okay, firewall, NGIPS, all these features, plus some extra features also. Okay. Okay. So then what happened? That if we talk about your FTD, so in FTD, we have two engines. Okay. In FTD, we have two engines. What are those? Number one, your Snot engine. Number two, D90. These are the two engines. Okay. So your Snot engine, it is responsible for L7 filtering, and your Lena engine, it is responsible for L3, L4 filtering. Okay. So in case of FTD, your traffic goes through these two engines. First of all, it will go to Lena, then it will go to Snort, then back to Lena, and then finally it will be either forwarded or dropped. Okay, the decision will be made. Now, even before source fire, okay, even before you had this source fire, so before source fire, there was an organization Snort. Okay, and the Snort was responsible, or it was very well known for open source ideas. Okay, they were known for open source ideas. Later on, SourceFire, they used their technology and they made SourceFire. Okay, they made their own SourceFire 3D system or the SourceFire devices. And later on, it was acquired by Cisco, and now it is Firepower. So from Snort to SourceFire to Firepower, this was the transition. Okay. So if I talk about, IDS and IPS, so do you guys know what is the difference between an IDS and IPS? Okay, Snort once again. See, before your source fire, okay, the organization was Snort. So Snort, what they did, they were very well known for the IDS. Okay, they were creating IDS. So SourceFire, they used their IDS technology. They used the Snort engine. Okay, they used the Snort technology to build up these devices, your SourceFire firewall and IPS. Okay, they used this Snort technology. And then later on, Cisco acquired SourceFire and it became what? Firepower. Now it is Firepower. Is it clear? Okay. So what I was asking is, are you guys aware about IDS, IPS? What is an IDS? What is an IPS? What are the differences? What is the difference between IDS and IPS? No. What about other people? Anyone who is aware? Okay. So understand, guys. IDS stands for Intrusion Detection System. Okay. And IPS stands for Intrusion Prevention System. Okay. So your IDS, what your IDS is going to do? IDS is going to detect. Okay, it is first of all going to monitor your traffic, whether it is incoming or outgoing traffic. And then if it finds that, okay, the traffic seems to be malicious, in that case, it will generate an alert. Okay. So your IDS is going to inspect the traffic and generate an alert if it finds the traffic malicious. So if the traffic is malicious, in that case, what your IDS is going to do? The IDS is going to generate an alert, but the IDS cannot prevent an attack. Okay. An IDS cannot prevent an intrusion. The IDS cannot prevent an intrusion. While on the other hand, okay, so on the other hand, your IPS track the traffic and you can inspect the traffic and can then reach an alert as well as take action if the traffic is malicious. Okay. So your IPS can prevent intrusion attack. Okay. So generally what happens if we talk about your IDS, so your IDS will, okay, your IDS inspect a copy of the traffic. Okay, so it will just inspect the copy of a traffic. So what will happen, if you just consider a sample scenario, okay. So let's say there's a small topology I'll go here. Let's say this is ASA. And then after you have a switch. Then you have your endings. And they are connected like this. So how your IDS will be deployed? Your IDS will be deployed in parallel like this. Okay. This is how your IDS will be connected. Normally you will have a, I believe CCNP everybody have completed, right?
Yes, sir.
Okay, then fine. Then you guys might already be aware about the span concept. Span, right? You guys might be aware about it. What is span? TCNP advance is pending. I think this should be in the switching. This should be a part of switching, I believe. In the switching, you might have studied about the span. So nobody has completed advanced or switching. 1 week left to complete. Like which module? In CCNP, which module you are having 1 week to complete? Okay, you are currently in routing. All right. So you will see about a span concept. Span concept is what that see, whatever the traffic, we have a switch here, right? This is a switch. So in this switch, whatever the traffic is traveling, whether it is going from PC1 to internet, from internet to PC2, from internet to PC1, or from PC2 to internet, whatever the traffic is going via the switch. So one copy of that traffic will go to the IDS. Okay. So when you configure span, so one copy of the packet always goes to the span port. And on the span port, you might connect IDS so that your IDS can inspect the traffic. Okay. So your IDS will not inspect the actual traffic. It will just inspect a copy of the traffic. Okay. And how your IDS will make a decision whether the traffic is malicious or not malicious. So IDS have a database. Okay. These IDS, IPS, firewalls, these will have what? A signature database. They have something called a signature database. Okay, this is not in case of ASA. Okay, in ASA, these kind of things are not there. just in case of IDS, IPS, and next generation firewalls, you can say. So they have a signature database. So in the signature database, there will be a signature of all the malicious traffics. Okay, there will be a signature of all the malicious traffics. So what will happen in the signature database? They have a signature, let's say, for example, something like, let's say this is a signature for a malicious traffic. So now what, whenever a traffic is coming, right, whenever a traffic is passing through the switch, so one copy will be sent to the IDS. What the IDS will do, IDS will check the signature. Whatever the traffic is there, for that it will capture the signature. So let's say it is the same. The signature is same, so it will match it with the database. Once it calculates the signature, it will match it. If they are matching, so that means this traffic is malicious, and your IDS will generate a alert. Okay. So simple thing is, whatever the traffic is coming to the IDS, IDS will calculate the signature and will match the signature with the database. In the database, if the signature matches, that means the traffic is malicious. Okay, small practical, let me show you about this. So let's say I will upload one malware. So let's say this is the Windows 7 I have here. Then let's go to the internet. And here I'll go to a website, virustotal.com, where I can check that, okay, whatever the file I have downloaded from the internet, whether it is malicious or not. Okay. So here, let me check, do I have the malicious file or not? This is Chrome installer. Anything I deleted here? This Chrome installer, this is also malware only, okay? All these directories are deleted. Okay, very good. So this Chrome installer, this is also a malware only, okay? This is not really a Chrome program. This is a malware that will just affect my system. And if you want to see how it will affect, so what it is going to do, this particular Chrome installer application, it is going to shut down my system. Okay, so if you want to see it, let me show you. I'll just execute it. I'll say yes and see what do I get. I get a pop-up that you are hacked, say goodbye to your system, and my system is shutting down. Okay. So this way, this is a malware file, not an actual program. So this is something that we have created and it is not malicious. It will just restart the system. Now we will see that is any security provider detecting it as a virus or not. Okay, so if the security service providers, they have the signature of this file in their database, they will consider it as malicious. Otherwise, they will not consider it. Okay, so let me show you. Okay, so it is available on my desktop. This is the Chrome installer application. I'll say open, and now you will see. So this is the signature. If you see, this is how a signature looks like. Okay, this is how a signature looks like. So this this is the signature that they have calculated for this file, and then they submitted this signature to all these different vendors and see how many of them are detecting. Out of 74, security service providing vendors, only 19 are detecting it as a malicious. Others, they are not detecting it. Okay. So see here, let's verify. Magnifier, I don't need to. Okay. So if you see, we have like a Fortinet will be detecting it. Then we have your Palo Alto networks. They will also detect it as a malware. McAfee will also detect it. Max Secure will also detect it. Okay. Then if you see other security service providers, so talk about your LE Cloud, Avast, Avira, Bitdefender. Okay, MCSoft is there. Google is not detecting it. Escan is not detecting it. Okay, Kaspersky, Malwarebytes. Okay, then you have Microsoft also not detecting it. Quick also not detecting it. Okay, because they don't have the signature. Sophos is also not detecting it. Okay, Symantec is not detecting it. Trend Micro is there. Tencent is there. So many are there. Like Webroot is there. See, so many popular service providers are there, which are not detecting it as a malware. Okay, which do not consider it as a malicious. So how do we come to know that okay, whether a file is malicious or not? Using this signature. So all your IDS, IPS or antiviruses or firewalls, they will what they're going to do? They're going to calculate the signature of the file and then they will match with their databases. So if there is an entry in the database, they will consider it as malicious. Otherwise, they will not consider it as a malicious file. Is that clear? And you see, what is the labeling they have given to it as a Trojan? What is a Trojan? Anyone aware about a Trojan? Okay, not a problem. So I believe you got an understanding how the IDS will, okay, how the IDS will detect and generate an alert. Yes or no? Okay, great. Now let's talk about IPS. So your IDS is deployed in the parallel, while your IPS is deployed in the series. Okay, like this. Your IPS will be deployed in this form. So what will happen? See, in this case, how our setup will look like. Okay, let me do something. So you have the internet, you have ASA, then you will have your IPS deployment. Then you have switch. And finally your end host. Okay, this is the setup, how it is going to be. And this is one. And this is your two. And this is your switch. This is your IPS. And this is your ASA. And this is the internet. So now what will happen? Whatever the traffic will be coming, right? Whatever the traffic will be coming from outside to inside. So the actual traffic will be going. Your IPS will be inspecting the real traffic. Okay, it will not inspect a copy of the traffic. The real traffic will pass through it. Again, for the real traffic itself, IPS will do what? IPS is going to calculate a signature. And that signature, your IPS will match it with the signature database. And if the signature matched, that means the traffic is malicious and IPS will drop that traffic, or else the traffic will be allowed. Okay. So, I believe you might have heard of 0 day. You guys might have heard of it, the term 0 day, 0 day attack, 0 day exploit. Yes, 0 day attack. So what it is? Yes, the real traffic. So what is 0 day? Any idea about 0 day? Cyber attack. Okay. See, 0 day means what? That there is a vulnerability that is present, but that is present, but that is not known to everyone yet. Okay, so let's say, for example, there is an organization in their systems, there is a new vulnerability I have found, and this vulnerability was never found before. Okay, okay. So what will happen? That whatever the payload I will use to exploit that particular vulnerability, the signature of that particular payload will not be present. Okay, it will not be present to any security service provider. Now what will happen? That when I will send the payload, so it is not there to anyone in their databases. So it will bypass all the security services. Okay. And I will be able to exploit that vulnerability. So a vulnerability that has been exploited but not disclosed. Okay. That is there, not disclosed, but exploited. That is what? A 0 day. Okay. A new vulnerability that has not been disclosed yet. That is the 0 day. Okay. So if your IPS, IDS or firewalls, they have the signature in the database, they will take an action, or else they will just allow it to pass. Is that clear? Okay. So this was, how from router to ASA to FTD, NGIPS. And nowadays these IDS and IPS, these are not separate devices. These come in a single one. Okay. So when we say that we are going with the NGIPS, so NGIPS has the capability of both IDS and IPS. Okay, because IDS is just capable of detecting it and generating an alert, but your NGIPS can do both. It can detect, generate alert also, take an action also. Okay, so all these things can do. So any doubt in this part? Because this was the basic that we have to understand. Now the next thing we have to start with is your basics of ASA, which we'll be studying tomorrow. Okay, we have to start with basics of ASA. Okay, so we'll understand about ASA. Sir, can security devices detect vulnerabilities? Vulnerabilities, for vulnerabilities, you have vulnerability scanners. Okay, you have vulnerability scanners for that. They cannot detect vulnerabilities. Okay, so vulnerability scanners, like you might be using NASA, okay, might be you will use OpenOS. Okay, and there are other also present. Your security devices, they cannot detect. If you have network mapping tools or vulnerability scanners, in that case, you can discover the vulnerabilities. Otherwise, you can. Okay, like a firewall is not going to detect a vulnerability. Yeah. Okay. Anything else? Any other doubts? So the next part that we will be starting tomorrow will be about the ASA, and we'll discuss about the Cisco ASA. Okay. So this is the next thing that we have to discuss about the ASA firewall. We'll go with the definition, history. Okay. So like we were talking about Cisco PIX is there, then you have VPN 3000. Along with that, if you want layer 7 filtering, so IPS 4200 series. These were the ASA models that we will talk about tomorrow. Okay. So about the models, what are the key features, hardwares, licensing, and finally the zones we will talk about. Okay. So this part is coming up tomorrow. Then later on, all other concepts like, what are there are certain rules, okay, related to security levels. So practical implementation will start, you can say. From tomorrow onwards, we'll start a little bit of practical implementation. Okay. So before that, I believe all of you guys are aware about EVNG. EVNG, are you guys already aware about it? Those who have taken any of the security batch already, they might be already aware. What about new people? Anyone who is not aware? Okay. I believe everybody is aware. That's good. Okay. So tomorrow in the eve only, we will be practicing about, the ASA and all. So entire ASA labs will be performing with them in the event. Clear guys? All right. Okay then. So today we'll wind up and tomorrow we'll start with the ASA. Please share ASA guide. Yes, I'll just do it right away. Okay, I'll just share it right now only. This is the ASA guide. No. Okay, this one also I'll share. The ASA guide. Okay, this is not there here. I uploaded it in some other batch. This is the guide. Okay, it is there in the drive. So you guys can refer to it. All right. Okay then guys. See you guys tomorrow. Have a good day.